Okay, so this is problem 11.1.71, and they ask us to find and evaluate the sum. And I'm going to write this out a little bigger so you can see it. So this is the sum from k equals 1 to 6 of k over k plus 3. Okay, so this is just summation notation, and literally all we're doing is we're summing from a k equals 1 up to k equals 6. That means that we're going to plug every whole number from 1 to 6 into this expression right here, and then we're going to sum them. Okay, so when I plug in k equals 1, I get 1 over 1 plus 3. And then I'm going to plug in k equals 2, and I'm going to get 2 over 2 plus 3. And then k equals 3 is 3 over 3 plus 3, and we just keep doing this until we hit 6. And 6 over 6 plus 3. Okay? So if we simplify, this is 1/4 plus 2/5 plus 3/6 plus 4/7 plus 5/8 and then plus 6/9. And I'm not really very sure how they want you to leave their answer here. I'm not sure if they want you to leave this with a common denominator, or if they want you to, maybe get a decimal out of this. Decimal would probably be the easiest way to do it, but let's do it with a common denominator because it's probably going to be how they're going to ask you to do it. Okay, so we have to find the common denominator between all of these. Really what we want to do is maybe do a tree and look at all of them separately. So if we take a 4 and break it down, it's 2 and 2. So that prime factored form is 2 squared. The 5, the denominator of 5 doesn't break down, so it's just a 5. The 6 breaks down into a 2 and a 3, so it's 2 times 3. The 7 doesn't break down, it's just a 7. 8 breaks down into 2 cubed, and the 9 is 3 squared. Okay, so if we look for the LCM in all of this, and this you may have to reach back in your mind to remember LCM, but that's identifying a common denominator. We're going to take a look at all of the factors, and we're going to take a look at however many times they occur the most in any one spot. Okay, so we have factors of 2, 3, 5, and 7. The 2 occurs at most 3 times right there, so we need it 3 times. The 3 occurs at most twice. The 7 occurs at most once, and the 5 occurs at most once. Okay, so if we take a look at 8 times 9 times 7 times 5, we get 2520. So that is our common denominator. Okay, so that's what each of these are going to be. And adding these fractions is probably the hardest part of this problem. So anyways, we're looking at the 2520, and it's 1/4, 2/5, 3/6, 4/7, 5/8, and 6/9. And 6/9 actually, well, we could have reduced these. This is 2/3. Why don't we reduce them actually? So we have 1/4, 2/5. This is a half, 4/7, 5/8, and then this is 2/3. Okay, so we got to figure out what we need to multiply by to get us up to 2520. So 2520 divided by 4 is 630. So I'm going to multiply this one by 630 over 630. So that becomes 630 over 2520 plus 2520 divided by 5 is 504. So I'm taking this one by 504 over 504. Okay, can't see that very well, but so 504 times 2, we get 1008 over 2520. This is going to be 2520 divided by 2 is 1260 over 2520. And then 2520 divided by 7 is 360. So 360 times 4 is 1440 over 2520. 2520 divided by 8 is 315, so I'm multiplying 315 top and bottom here. So 315 times 5 is 1575 over 2520. And then 2520 divided by 3 is 840. So 840 times 2 is 1680 over 2520. All right. So anyways, so if we add all of this together, we have 630 plus 1008 plus 1260, 1440, 1575, and 1680. So you get 7,593 over 2520. That's probably how they're wanting you to leave the answer. You could, divide that and get a decimal, and I don't think they're going to take it as a decimal, but it ends up being 3.01 and then it goes on. Okay, but this is probably going to be what they're looking for, and I don't believe that will reduce. Let me just look at it for a minute. Oh, it does look like it reduces. So 2520 divided by 3. Yeah, so let's reduce it. So they're both divisible by 3. So 7593 divided by 3 is 2531. And then 2520 divided by 3 is 840. Let's see if it's still reducible. I don't see it reducing beyond that. So this is probably your answer. This is probably what they're looking for. 2531 over 840.